Every industry today relies heavily on software systems. These systems, whether simple or complex, are built upon a foundation of 4 core layers. Think of it as a state engine: collect, store, recall, and present. This framework has served us well, but the advent of artificial intelligence demands a critical look at these layers. Understanding how our current systems operate is crucial to effectively integrating the transformative power of AI. The first layer, collection logic, focuses on capturing real-world data and translating it into a digital format. This layer involves various components: physical assets equipped with sensors, transactions occurring within the system, and any modifications made to entities within the system. The technologies employed in this layer are diverse, including enterprise resource planning systems, point-of-sale systems, Internet of Things devices, radio frequency identification technology, and application programming interfaces. Major players in this domain include Microsoft, SAP, and Salesforce. This layer requires the expertise of ERP consultants and API developers to ensure smooth data acquisition. Challenges arise from the complexity of integrating various data sources, potential data duplication, and the need for manual validation. Once the data is collected, it needs to be organized and stored effectively. This is where storage logic comes into play. This layer involves structuring the data for long-term durability and easy access. 2 primary components are used: structured databases and unstructured data stores. Structured databases rely on technologies like SQL, while unstructured stores utilize NoSQL databases. Leading providers in this area include Microsoft, Oracle, open source like Postgres. Database administrators and data engineers are essential for maintaining and optimizing these storage systems. Challenges in this layer include the rigidity of predefined database schemas, ensuring scalability to accommodate growing data volumes, and enabling semantic understanding of the stored data. Finding meaningful information, recall logic. Having vast amounts of data is useless without an efficient way to retrieve specific information. Recall logic addresses this need. This layer encompasses the tools and techniques used to extract valuable insights from the stored data. Key components include query languages, powerful search engines, and data aggregators. Technologies like SQL, GraphQL, and Elasticsearch are commonly employed. Elasticsearch, Oracle, Microsoft are major players in providing search and retrieval solutions. Data analysts and search engineers play crucial roles in formulating queries and optimizing retrieval processes. Challenges arise from the complexity of queries, limitations in semantic recall, and the computational cost associated with retrieving information from massive data sets. Making sense of it all. Presentation logic. The final layer, presentation logic, focuses on transforming raw data into meaningful insights and actionable information for end users. This often involves generating reports, creating interactive dashboards, and designing intuitive data visualizations. Front-end technologies like HTML, CSS, and JavaScript are crucial for building user interfaces. Companies like Microsoft, Tableau, and IBM provide powerful tools for data visualization and reporting. Front-end developers and UX designers play vital roles in creating user-friendly interfaces that facilitate data exploration and understanding. Challenges in this layer include the static nature of traditional reports, inconsistencies in user experience across different platforms, and the ongoing maintenance required to keep interfaces up to date. The limits of traditional systems. While the traditional 4-layer architecture has served us well, it imposes limitations in the age of AI. These systems often lead to a loss of context as data is broken down and stored in separate silos. Retrieving information across these silos can be inefficient and time-consuming. While effective for rule-based systems, these architectures can become a bottleneck when dealing with the complexities of AI. The problem lies in the fact that most current systems are modular and were designed in a pre-AI world. AI has the potential to revolutionize each layer, from intelligent data capture to intuitive user interfaces and autonomous decision-making agents. However, many organizations treat AI as a high-cost ornament, bolting it onto existing systems without a clear strategy. This often leads to disappointing results and missed opportunities. The solution lies in conducting a deep audit of existing software structures. This involves identifying bottlenecks, eliminating data silos, and reimagining workflows to fully leverage the power of AI. Only then can we unlock the true potential of AI and build truly intelligent systems for the future.